Hi everyone. In this video I'm going to share about Lenz Law electromagnetic induction. Okay. In the previous video we learned about Faraday's law, and Faraday's law from magnetic fields we can provide induced current. However, at the end of the video we discover that this negative symbol means that the induced current is negative. Why? Why is current negative? Okay, explained by Lenz law. Mentioned that the direction of induced current by changing conductor magnetic field is such that the magnetic field created by induced current oppose the initial changing magnetic fields. So this is negative. So in this view, I will explain the detail where the negatives come from. Okay. Now let's consider these two magnetic fields and conductor. So we have two conductor. These two scenario. First scenario like this. First scenario, okay, we use that we studied before about Ampere's circuital law. Mentioned that when the current in the conductor, current flow like this, there will be magnetic fields around it by using a right hand rule. Okay, so when we use the right hand rule, the magnetic field will be like this. Okay, so we take this case same as this one is current, this one is magnetic field. Okay, current like this, let's say current flow like this way, and also this. Okay, when current flow, this indicator we call this one is anti-clock cycle. And anti-clock cycle, what happen if we use circuital law, Ampere's circuital law? So okay, this is the magnetic field created by the induced current. This induced current created by this magnetic field. This magnetic field produce induced current. Then this induced current will produce magnetic field. Okay, this induced current flow through the conductor. Based on Ampere's circuital law, when current flow through the conductor, there will be magnetic field. Okay, when current flow through the conductor, there will be magnetic field. So when this current flow through the conductor, so there will be magnetic field here. This one. Okay. Okay. This one we use right hand rule. So from this magnetic field that created by induced current, same direction with the magnetic field created by this permanent magnet. The magnetic field this way, and also for magnetic field produced by this induced current this way, same direction, means that this will be add together, combined together. So the total magnetic field will be increased. Magnetic field will be increased. Okay. Okay. So when magnetic field increase, we know that Faraday's law say that magnetic field produce current. So next, this magnetic field will produce another we call another induced current, second induced current. Okay, okay, red color. This new magnetic field, the summation of magnetic field from the original permanent magnet and the magnetic field created by the first induced current here. So total this magnetic field will be higher. Then when this magnetic field higher, so based on Faraday's law, induced current will be produced here. So another induced voltage, another induced current here. This induced current higher than the previous current because the magnetic field higher. Then this induced current, if we use same direction like this induced current will be produced like this. So this red color same direction with this one, so we have to plus another magnetic field. This magnetic field produced by this one. So then this magnetic field higher. It look like keep on increasing, magnetic field increasing. So next we produce another another induced current. This induced current will produce another magnetic field. So it look like keep on continuing adding until infinity. Does it make sense? I think no, because it look like we're creating more energy. It is against the conservation of energy. The conservation of energy say that the energy in a closed system remain constant. So in this case, in this case, look like we adding more energy. If we assume flow of induced current like this, anticlockwise. Okay, definitely. Okay. Let's look at the second example. Okay, we assume induced current this direction. So opposite of the secretarial law, opposite of this. So when induced current turn like this, let's say induced current, we know that when induced current like this, use our right hand rule. So the magnetic field will be like this. Okay, this magnet, we can see that the magnetic field that produced by this induced current against the magnetic field produced by permanent magnet. Okay, this permanent magnet go to the right. This magnetic field produced by the induced current go to the left. So this magnetic field against the existing magnetic field. Okay, so the total of the magnetic field, this magnetic field plus the magnetic field will be reduced. This makes sense compared to the previous one, because the previous one keep on increasing. This in this example, this technique, the magnetic field reduce. So this is what we call Lenz law. Okay, Lenz law. He followed the third Newton. He also follow the Newton third law of motion. Every action there is always an equal and opposite reaction. So that means this this induced current, is against the magnetic field that created it. Okay, this induced current created by this magnetic field, from permanent magnet create this current. However, this current is against this magnetic field. Okay, that's why negative here. Means that it oppose direction of induced current oppose the initial changing magnetic field. This magnetic field, this magnetic field is from paramagnetic. This magnetic field produce the induced current. However, the induced current is against the direction of the current is against it. Okay, so means that the conservation energy is follow, and also the Newton third law of motion also follow. Okay, that's all. Thank you.